due to a ring of charge at different points. Here what we are going to focus is electric field due to a ring of charge at different points. And you know that if there is a ring and the ring is given a charge q, the total charge on the ring is q, and the radius of the ring, this is the radius of the ring from the center, this is equal to r. And from the center, you know that this is an axial line from here to here. It's an axial line. Suppose at a point P, which is at distance x from the center to this point P is at distance x. What is the electric field at this point? You know that electric field at this point is k q by r square plus x square whole power 3 by 2 into x. This is what we know. We also know that k is 1 by 4 pi epsilon naught. In a more formal way, we can write 1 by 4 pi epsilon naught into q x by r square plus x square whole power 3 by 2. And if charge density is given, if the radius is r, the total length of the ring is 2 pi r. If charge density of the ring is lambda, if charge density, we call this linear charge density. If linear charge density is lambda, then you know lambda means charge of 1 meter square. If the total length of the ring, because radius is r means total length of the ring is 2 pi r, then the charge by unit length is equal to lambda, then the charge is equal to L into lambda. Here length, the total length of the ring is 2 pi r into lambda. So if charge density for this is given, in this charge q, you have to replace it with lambda into 2 pi r. For such problems, you have to be very careful. Okay, now there are two major points where we would like to find out electric field. One is depends on this x. If x is far away from the ring, because this is the ring, this is the center, if x is far away from the ring, x gets very large, so that r becomes, compared to x, r is very small. So there are 2 points where we would like to find out. One is at far away points from the ring, what is electric field? The second is very close to the ring, very close to the center of the ring, because the x is on the axis, right? The x is the distance in the axis. So the moment it gets very close to which point of the ring? Close to the center of the ring, at very close to the center of the ring. What is the electric field? Okay, now let's look at this. The point is at far away points, you know that suppose you consider a value like 1 which is far less than 100. When you square it, or when you take 0.1, when you square it, it becomes 0.001, whereas this becomes 10,000. So which gets even far less than 10,000, right? Whenever one value is less than the other value, very less than the other value, whenever you take a square of that, the smaller value gets even smaller and the larger value gets even larger, so that compared to the larger value, smaller value gets like kind of negligible. So at faraway points, here we are considering at faraway points. So faraway point means that x is so large compared to r, then x square is even larger compared to r square. Then when you add x square with r square, because it is very very small, the total value becomes almost equal to x square, but not x square plus r square. For instance, in the example that I have given, when you square like 1 square and 100 square, when you add 10,001, which is very close to 10,000 only. Similarly, this one. But very close to the center of the ring means x gets very close. So x is far less than r, and hence x square is even lesser than, far less than r square. In such cases, when you add x square with r square, you get almost value equal to r square because r is larger. Here x is larger, hence you are getting x square. Because r is larger, you are getting r square. Then what is the electric field in those points? Electric field at a far point equal to 1 by, so I'm using basically this equation, I'm going to substitute that. So that is 1 by 4 pi epsilon naught into qx by, in place of r square plus x square we are going to put x square, so x square whole power 3 by 2. Whereas here electric field at a near point close to the center is 1 by 4 pi epsilon naught into qx by r square plus x square is r square whole power 3 by 2. We are going to get some interesting results based on which there is another JEE problem. So what is that? Here 1 by 4 pi epsilon naught can be written as k q x by x square whole power 3 by 2 is x cube, so x cube, so this is equal to k q by x square. Electric field at a far away point, and electric field at near point is equal to k q by r square whole power 3 by 2 becomes r cube into x. Now you see electric field here, electric field at a far away point behaves like a point charge, because from a point charge q at a distance x, electric field is k q by x square. That means 1 by 4 pi epsilon naught q by x square. So electric field at a far away point from the ring, electric field is inversely proportional to square of the distance, which you should not forget. Then electric field at a near point to the ring, electric field at the near point to the ring is k cube by r cube. R is the radius, q is the charge given, k is 1 by 4 pi epsilon naught, all are constants. So this is equal to some constant into x, hence this is directly proportional to x. So at a point close by, closer to the center, electric field is directly proportional to x, and hence electric force is also directly proportional to x. But here electric force or electric field is inversely proportional to x square.